Have you ever looked up at the stars and wondered what will eventually happen to them? Have you ever looked at the Milky Way, or a nebula, or a planet, and wonder how they will look like in the future? Well, I'm here to answer that question. Welcome to the third episode of The Universe in Magnitudes, the series where we look at how the universe will be like in the future, one magnitude at a time. Today we will explore the universe 100 years from now. If you haven't seen the first two episodes already, I'd recommend watching them first, so you can watch the series in chronological order. With that said, let's begin. Let's start off this episode somewhere where we haven't started a video before. Earth. In 100 years, Earth as we know it today will look very different. Because of human activity, our planet is changing faster than ever before. Forests that still exist today could be gone, while some other places that are currently frozen grasslands might grow forests because of global warming. There will likely be new countries, and some countries that exist right now might be gone. It is also possible that by now, the North Pole is entirely ice-free during the summer in the Northern Hemisphere. Let's move to the outer solar system. In the last episode, I said that in 10 years, every planet in the inner solar system would complete multiple orbits, but the planets of the outer solar system wouldn't even complete a single orbit. So what about now, in 100 years? Well, Jupiter has now completed around 8 orbits, Saturn has completed 3 orbits, Uranus has completed 1 orbit, and Neptune has completed just over half an orbit. 100 years is roughly the time it takes for Neptune to go from summer to winter. So even in 100 years, not all planets in the outer solar system will have completed an orbit around the Sun. Sticking with Neptune for a second, let's look at its biggest moon, Triton. Apart from Titan, the moon of Saturn, Triton is the only other moon in the solar system with an atmosphere. However, every 100 years, something interesting happens with this atmosphere. It freezes. You see, during Triton's southern hemisphere winter, it becomes a lot colder. This causes the nitrogen in the atmosphere to freeze and snow down onto the surface. Due to the nitrogen freezing, there is a lot less gas in the atmosphere, causing it to become noticeably thinner. The same thing happens for Pluto. It too has a nitrogen atmosphere that freezes in the winter. Going beyond even Neptune, let's look at Sedna. Sedna is a dwarf planet around half the size of the Moon. What makes Sedna so interesting is that it has an extremely eccentric orbit. It gets as close as 76 astronomical units and as far away as 937 astronomical units. In 100 years, Sedna will have passed its aphelion, which is the point in its orbit that is closest to the Sun, and it will start moving away from the Sun again after that point. If we want to send a probe to Sedna, now is our chance, because it won't be coming back for the next 12,000 years. In the Milky Way, there are around 3 supernovas every 100 years. However, the majority of these supernovae aren't visible to us. The reason for this is because of the Milky Way itself. You see, the bands that form the Milky Way are made of gas and dust. This gas and dust, however, blocks out the light from most parts of the galaxy. They are like giant walls, blocking any light further than a few thousand light years away. However, supernovas outside the Milky Way are in almost all cases visible to us. Over the next 100 years, we are likely to see supernovae in one of the Magellanic Clouds, the Triangulum Galaxy and the Andromeda Galaxy, and possibly in one of the many dwarf galaxies in the local group. These supernovae could be observed with our modern telescopes to better our understanding of the universe. As you can see, on the timescale of 100 years, a lot of exciting things happen in the universe, but we have just barely begun. Every episode, we look an order of magnitude further into the future, and the changes become bigger. So if you want to know how the universe will look like in 1,000 years, or a billion, or a quintillion, make sure to subscribe, because the timescales are now starting to increase rapidly. I hope you enjoyed today's video, and I will see you in the next video.